Hi everyone, I am Daksh Arora, roll number 220101033. In this video, I am going to show you something very interesting, how Fourier regression can find patterns in data that you just cannot see by looking at it directly. So here is the starting point. I took this Google Trends dataset from the tutorial. It tracks how often people in India search for restaurants near me. Yeah. Over about 30 days, this data. From mid January to mid February 2026. When you look at the raw data, uh, you might notice it goes up and down, but it's like very hard to say much more than that just by looking at it. So, the question I want to answer is there any hidden pattern here? And can Fourier regression find it without us telling it what to look for? Okay. Quick recap of the idea. A Fourier model says we can write a signal as sum of cosines and sines, a DC term plus harmonics. The key thing is we pick t equal to total length of our data, 30 days. We are not assuming any weekly pattern or daily pattern. We are just giving the model a mathematical canvas to work with. We then set up a design matrix where each column is one of these cosine or sine terms, and we solve a regular least square fitting problem to find the best coefficients. It's just linear regression but with sinusoidal basis functions instead of polynomials. Now let me switch to the code. Yeah. So here is the design matrix function. Each column is either a cosine or sine at different harmonic frequency, nothing fancy, right? Now I fit the model with k equal to 1, 4 and 10 harmonics and plot the results. With k equal to 1, the fit is too smooth, it misses a lot of structure. With k equal to 4, it is starting to look pretty good. With k equals to 10, the it tracks the data really closely. So if I plot training error versus k, you can see it goes down monotonically. That is expected. More harmonics always help in always helps in training data, but we don't want to overfit. So somewhere around k equal to 4 or 5 is like the sweet spot for this data set. Okay. So here is the main result, and this is the part I find really cool. After fitting the model, I computed the amplitude of each harmonic, that is just square root of a underscore k squared plus b underscore k squared, square root of all this complete term. Yeah, here it is. I then plotted amplitude versus frequency. So look at this. There is a very clear dominant spike roughly around f equal to 1 by 7, and yeah, a weekly cycle basically. And remember, I never told the model anything about weeks. I didn't say assume period equal to 7. I just said the reference period is 30 days and fit the harmonics. The model found the weekly pattern on its own just from the numbers. You can also see a few smaller spikes just around the dominant peak. Those nearby harmonics help the model capture asymmetric shape of the weekly cycle. Sorry. The sharp rise into the weekend and slower drop back down on weekdays. So this is the whole point. Looking at the raw data in time domain, you might guess there is some weekly pattern, but it is not obvious. Looking at the frequency domain, it jumps out immediately. So what does this actually mean? The DC component, the A0 term, is just average search level, about 70 out of 100. The dominant harmonic is at 1 by 7 and it is the weekly rhythm. People search for restaurants more on weekends, especially Saturdays and Sundays, and less at the start of the week. The smaller spikes around the dominant frequency capture the fact that weekly shape is not a perfectly sine wave. The week end peaks are sharper and weekday dips are flatter. Those neighboring harmonics are what give the curve that asymmetric shape. This kind of insight is something you can only get once you move to the frequency domain. Time domain tells you what happened. Frequency domain tells you why it repeats. So, yeah. So to wrap up, I can say I use Fourier regression on real data set with no prior assumptions about its period. The amplitude spectrum revealed a clear 7-day cycle in restaurant search behavior. The main takeaway is that Fourier analysis doesn't just fit a curve to the data, it changes how you think about the data here from like what the values look like to what actually is the pattern. So this is it. This is the summary. Thank you for watching.